Good morning or afternoon, depending on where you are, and welcome to the fourth of four webinars on preparing for the C3 Advanced Surveying exam. I'm Kevin Jones. I'm the examinations administrator for CBEPS, and I'm moderating the session. Presenter is, as with the other three, Dr. James Secord, professor at the Geodetic and Geomatics Engineering Department at the University of New Brunswick, and I will hand it over to James.
Okay, thank you, Kevin, and welcome to everyone. As Kevin mentioned, this is the fourth and final in the series of webinars. This is the agenda for today. The first part of it is a rehash as you've seen in the other sessions. So I'll quickly go down to the one that's important for today, and that's item 4.5 on the agenda, which is basically the fourth session. Our initial focus will deal with underground surveying, the essential reference material that's listed there, and the study questions that are listed that pertain to those. Once we've dealt with any concerns of those, we'll go on to deal with virtually anything. And the only thing that I have noticed that has appeared on the forum since our last session was a question about study question 12, which I'd be willing to revisit if that is your wish. So I guess it's to some extent up to everyone else now to suggest what I should do. I'll just make one note that study question 9, which is basically all of the questions at the end of the chapter that's been authored by Jernowski and Robinson. The chapter on mining surveying has an extensive amount of calculation, the use of a lot of formulas, and the trick there is to go through the chapter, notice the units that go into the formulas, and each one has been evaluated as an example, and be very careful when you do calculations that you use the proper units, because sometimes they switch from meters to centimeters to millimeters and all over the place. That's largely an attempt to make the formulas relatively simple, but it then does take a bit of vigilance when you're using the formulas. If you go through the questions that are at the end of that chapter and do them properly, you should get the proper answers as are listed in the study guide. If you have any particular questions, I would be willing to deal with those straightway. One other bit of explanation that I could offer is that in this chapter by Jernowski and Robinson, that's out of Davis, Foote, Anderson, and McHale, Surveying Theory and Practice, there is reference quite often in that chapter to other portions of the textbook. And there is a supplement, DFAM, let's see, I think the file is DFAM 1981, yes, which is the material that is out of the other portions of the textbook. So if you have to look up a particular formula or go to a certain section, those have been provided in that. How about any of the other topic areas, the ones for which we have already had sessions? I noticed there was that one question on the forum for study question 12. Would you like me to go over that?
We have a request for study question 16.
16? Okay.
Yes, please.
So I'll go to the study guide and question 16. Okay, study guide question 16 deals with going from the surface to underground. The first part of the question deals with going horizontally, and the second part deals with going vertically, in other words, taking elevations and transferring. Basically, it's not really transferring elevation, it's transferring distance, and the vertical is really the B part. If you go through this chapter 20, which is basically that first reference that's listed after the question, there is a fair amount about using plumb lines. There is some mention towards the end about using optical plummets, and although it was authored in 1981, about the only difference now in current optical plummets might be that you could use a laser eyepiece in it and either plumb up or plumb down. So plumbing up would be a zenith plummet, plumbing down would be a nadir plummet. It's a little different than the optical plummets that you use in the tribrax because there's a much higher precision to the definition of the vertical through the level vial or automatic mechanism, and then the focus is much more sophisticated. It's basically a telescope that's looking through a prism either straight up or straight down. One of the problems with using an optical plummet is visibility. Obviously you have to be able to see whatever's at the other end in order to line it up with the image of the crosshairs. So usually the limitation on using an optical plummet is visibility. However, there's also the problem that with an optical plummet you either have to be above or below where you're wanting to have the horizontal positioning done, which means if there's a sump at the bottom of the shaft, there would have to be a fairly sophisticated platform, and you can imagine how sophisticated it would have to be in order for the instrument not to be vibrating. And similarly, there would have to be a similar type of effort up above. The advantages then with the plumb line would be that there is almost no limit to how deep you can go. The deeper you go, the heavier the wire and the greater the weight that's put onto the end of it. And we have ways of calculating what sort of variation there would be. And as you notice from those formulas, that also the deeper you go with the plumb line, the more uncertainty would be associated with the transfer of the horizontal position. Now, position transfer is basically using one plumb line, taking the coordinates of the top and projecting it down to the lower level. Orientation transfer then requires something to be done to get a second point. One way is to use a second wire in the same shaft. They're very close together, so there is a concern with this very short base being propagated over the full length of the workings that would be underground. The possibility when doing things with high relative precision, as illustrated in the Robinson et al. Paper from 1995, which is basically discussing how things were done with the super collider. The major difference there is that it was for a tunneling effort where the tunneling was fairly close to the surface, so they could take advantage of these shorter sites and use a fairly sophisticated method using precision electronic total stations as well as the optical plummets. This Taylor-Hobson sphere is a special manufacture where the target has been placed at the center of the sphere with a very high tolerance, meaning that it's very accurately placed to the center of the sphere. So regardless of the orientation of the sphere, if you sight at the target, you're always sighting at the center. So you can sight to the target from the surface, turn it so that the target portion of the sphere is looking downwards and you're maintaining the same point, and then the optical plummet looking up could then be centered with the translation stage underneath the center of the sphere, which then transfers the horizontal position. And if you have two of them, then you've got the base to transfer the orientation.